Okay, well, we're picking up with our second part of the solutions to practice test 3B from college algebra. We did 1 through 15 on the first video, so we're going to start with question number 16 here. The time t required to do a job varies inversely as the number of people working. Okay, when you see t varies, that's t equals some constant. If it's direct variation, we multiply. If it's inverse variation, we divide. So if we let t be the time required, n is the number of people, its inversely is n, so we divide by n. So there's our formula. Now, k is a constant, n is our variable, t is our variable. So n's like x, t's like y. K is an actual number, a constant number. So we need an initial condition, in other words, one ordered pair of n and t, to figure out k. And they tell us that in the next sentence. It takes 7 hours for 4 cooks to prepare the food for this job. In other words, to complete the job, which is food for a wedding rehearsal dinner. Okay, so that now we multiply both sides by 4, and we get k is 28. So the formula is t equals 28 over 4. N must be measured in number of people and t in hours. How long will it take 3 cooks to prepare? I'm sorry, this should be a variable. Wrong. N is a variable. There we go. And now this time, how long would it take 3 cooks? N is going to be 3 this time. And this will allow us to solve for t. So in this equation here, we can solve for n or solve for t. It's already solved for t. So if we know either n or t, we can find the other one. So it's 28 thirds. So that's 28 divided by 3. 9 1/3, or 9.3 repeating. Round to the nearest tenth, 9.3 hours. Next question. 17. Find the equation of variation where y varies inversely as the square of x. Y varies, y equals k. Inversely is divide by x squared. So there's the equation, but we don't know what k is. So we know if y is 0.48, then x is 0.1. So 0.1 squared is 0.01. Actually, if you multiply by, let's see, 0.01 on both sides, that will cancel that out to solve for k. So it's 0.0048 is k. So y equals 0.0048 divided by x squared. And that's what we have there. Determine the symmetries, if any, of this graph. Y equals absolute value of x minus 4. Notice if we replace x by minus x, that's going to reflect over the y-axis. And when we do that, the absolute value of x is the same as the absolute value of minus x. So these are the same. So it has y-axis symmetry. Yes, on that one. If we replace y by minus y, like this, that's not the same. So no matter which way you write, it's not the same. So this is no on x-axis symmetry. And if you do both, change y to minus y and x to minus x, that will reflect about the origin, and that's not the same as the original. So no on origin symmetry. So the correct answer is symmetric with respect to the y-axis. Okay, symmetries here. X squared plus y squared equals 3. If you replace x by minus x, it reduces to the same. So it has y-axis symmetry. If you replace y by minus y, it stays the same. So it has x-axis symmetry. And of course, if you do both, then it still stays the same. And that is origin symmetry. So it has all three. This is actually a circle centered at the origin, radius square root of 3. Even, odd, or neither. Well, if you reflect this about the, remember, even is if f of minus x equals the same thing as f of x. That's what we mean by an even function, but that turns out to be the same thing as being a function and having y-axis symmetry. We don't have a formula, so we're not going to be able to check it this way. We're going to check it by the graph. Well, it doesn't have y-axis symmetry. For example, this point right here that you can see at the top here, if it had y-axis symmetry, there would be a corresponding point right in here, and there's not. So no y-axis symmetry, so it's not even. To check for odd, the algebraic condition is f of minus x is the opposite of f of x. That's called an odd function. Graphically, that turns out to be the same thing as being a function and have an origin symmetry. And of course, it could certainly be neither one. It's not going to be both unless it's just y equals 0. So it's not going to be both. Could be neither one. In this case, it's not. We already found out it's not y-axis symmetry. It does, however, have origin symmetry. If you rotate this part around, it'll match that, and this part will come back around to match that, and so forth. So it does have origin symmetry, so it is an odd, and it is a function, of course, so it's an odd function. F of x equals 2x to the 6th minus 2x squared. The even powers here, if you put in the opposite of x here, in other words, change y, leave y alone, but change the sign on x, that's going to reflect over the y-axis. But the even powers here, that turns out to be the same. So it's an even function. This is the same as the original f of x. So f of minus x is the same as the original f of x. Those were the same, so reflecting over the y-axis left it the same. Here they have the graph. You can see it graphically. It looks like it has symmetry with respect to the y-axis. We checked it algebraically. It sure enough does. So it's symmetric about the y-axis, and that makes it, and it's an even function. Same thing there. All right, next one. Let's see. This is 22. We start with f of x equals x, y equals x. Of course, that's just slope 1, line like this. Now, they're going to first think of it as a vertical stretch or compression. So, in other words, y equals x is what we have to begin with. Then we're going to change it to y equals 5x, which is the same thing. If you want to think of it as a vertical change, you need to think of it in terms of the y. So that's y over 5 equals x. So that's a vertical stretch, or an expansion vertically 5 times its tall. So in other words, we change the slope from being 1 to a slope of 5. So it's steeper. We stretched it vertically. Now we're gonna take care of the next thing they're going to do is reflect. So that's going to take care of the changing the sign on y. Minus y equals 5x. And that's going to reflect over the x-axis. So that's y equals negative 5x. So if that reflects over the x-axis, now it's coming down this way with a negative slope. And then finally, we're going to shift it vertically by taking this one and doing y plus 5 equals negative 5x, which solving for y is y equals negative 5x minus 5. But from here to here, we see that the y has been changed to y plus 5, so we really subtract 5 from the y's. So we've shifted the y-intercept down here at negative 5, and then we still have the same slope as we had here. So, let's see. It's stretched vertically, reflected across the x-axis, and shifted down 5. That was A, and the one that looks like that is B here. Okay, how can we get this next one? Of course, now remember on the graphing calculator, you could graph this and just see which one of these matches. I did it without a graphing calculator, but you can certainly graph this. Negative 5x minus 5. Of course, we know a lot about linear functions. We know that this will have a y-intercept of negative 5, 0, negative 5, and it's going to have a negative slope. That alone is enough to tell you it's got to be B. And we can graph all of those once we solve for y, we could graph each of these steps if we put in, you know, this one, this one, this one, and this one as y1, 2, 3, 4. You can see that in stages. Okay. Next one. Okay, so we see that this is basically looks like y equals the cube root of x, or x to the 1/3 power. We know x to the 1/3 power is going to look like this in the first quadrant and have a rotated image here, so it looks something like that, which we can also graph if we want to do it in stages here. X to the power 1/3, and we could graph that. Now, what do we want to do? We want to look at it in terms of a shift and a horizontal shift and a vertical stretch or compression. Okay, so let's do the shift first. That's a change in x, and if we look at it, we replace x by x plus 2. So that's going to be shifting. You really subtract 2 from the x's, so that should shift it over to the left 2. So it looks something like that. Okay. Okay. So in the calculator, we'll write x plus 2 to the 1/3 power. Power in parentheses, of course. And so we could graph that. And there's our shift to the left, like we expected. So it was left 2, so that's C. And then the 1/5 out front, say we modify this one, 1/5 cube root of x plus 2, we're going to think of that as 5 times y equals the cube root of x plus 2. So we see that that's a change in the y side. Replace y by 5 times y, which we really do is we divide the y's by 5. So now this is going to be a lot skinnier, not as tall, I should say, like that, closer to the y, to the x-axis. So the y's will all be 1/5 of what they were before. To put this in the calculator, we'll write it as y3 is, well, we could do 1/5 and then times x plus 2 to the 1/3. Okay, and so let's go ahead and do that. 1/5 and then x plus 2 to the power 1/3. Let's make that one darker by hitting enter there. And so the dark one is the final one, and notice it is kind of like what I have here. And so that was shrunk by a factor of 1/5 vertically. Shrunk vertically. Alright, next, do this in stages. So the first one is y equals x squared. And we want to eventually end up with y equals 2x minus 2 squared minus 3. So over here the 2 is attached first and then the 3 at the end. Those are actually changes in y. But so let's do that in stages here. Let's do the 2 first. So y equals 2x squared, or in other words, y over 2 equals x squared. These are the same, but we changed y. So we know y equals x squared basically looks like this. So the next thing we can do is let's see, multiply the y's by 2. So now it's going to be a little bit taller, twice as tall, or stretch vertically. And then we can do now we could do the minus 3. So we replace from here, replace y by y minus 3, y plus 3 actually. Okay, which is the same thing as y equals 2x squared minus 3. and so that's going to shift it actually down 3, so this is at -3, just like this one, but shifted down. This one's taller than that one. And then, so these are the same. And then the last one is to get to here, which is replacing x by x minus 2, which means you're really adding to the x's, so you're going to shift to the right 2. So that vertex now should be at 2, -3, and it should be taller and skinnier than the original one, which is in blue. So the original one is in blue, and then 2, -3, I believe, on this scale, I believe is this one, and that's the one that's taller and skinnier. This has got the right vertex, but it's wider instead of, I mean, it's yeah, wider or shorter. This one's the one that you want to see. Now, of course, all we really had to do was to graph these things. That might have been faster than thinking about all that stuff. So we might have done this one a lot faster by just saying y equals x squared, and then go ahead and graph the new one, 2 parentheses x minus 2 parentheses square minus 3. Graph those together. So there's the blue one, and the green one is there, and just see which one of those matches best, and that's C. So didn't have to really even think about it in terms of transformations if you didn't really want to. Okay, so if we have a point -16, 4 on the graph, and that's y equals, g of x. And now we're going to do, I'm sorry, that's y equals f of x, is got this point on it. And we're going to look at the graph of g of x, or y, equals 4 f of x. Well, that's y over 4 equals f of x. So from this one to this one, we're changing y to y divided by 4, so we really multiply the y by 4. So now the y is going to be multiplied by 4. It's going to be up here. It's going to also be at -16. So this is -16, -16, positive 16. So you're just going to multiply the y by 4. So it's a vertical stretch. -16, positive 16. So we're just seeing what we're doing numerically with the table or a point. 26, we have -12, 9, somewhere over here. -12, 9, somewhere over here in the second quadrant. Okay, and that's on the y equals f of x. Okay, the new point we want is on the y equals f of minus x. Well, from here to here we change the sign on the x. So we change the sign on the x. We're over here on this side at +12, +9. So we're reflecting over the y-axis there. Okay. -14, 2. That's right down in here. -14, 2. And we want to, that's on y equals f of x. And now we want y equals f of x plus 1, or in other words, y minus 1 equals f of x. So it's a change in y, not in x. If it's got to be inside the parentheses, there to be a change in x. So this is something that's going to change the y coordinate, but not the x. So it's still going to be here on this vertical line at -14, but the y says y minus 1. We really add 1 to the y. So now we go up a little bit. So that point's there. And what we want is -14 and then 3. So it's a vertical shift by 1. Up. 1 up. Okay, so the same shape as y equals x squared. Basic shape there. But upside down and shifted to the right 7. So upside down would change the sign on y. So that's going to go this way. And right 7 would be replace x by x minus 7. So that would be over here, 7. And then if we solve for y, it would be minus x minus 7 square, like that. Now we can just double check that by clearing this out. Let's see here. Leave that y equals x squared, but leaving this, I'll clear that one. Let's see. Negative parentheses x minus 7 close parentheses square, and let's see if that is the same shape but shifted to the right 7 and upside down. It looks like it is, so we're in good shape there. Alright, here's one where we're given the we're not given a formula, we're just given a graph. So the original graph is y equals f of x. So we start with the original one, that's the original graph, and we want to change it to y equals negative 3 f of x. So in other words, y over negative 3 is f of x. So we replace y by y minus 3. That actually does two things. Well, it multiplies all the y's by negative 3 is what it does. So that's going to flip it on the other side of the x-axis, but also make it 3 times as tall, 3 times as far away. So this one's going to go down and then 3 times as far down, so it goes down to here. This one's going to, the ones on the y-axis will stay the same. So it's going to go, this goes down, up, down. This will go up, down, up. This one here, I believe. Let's look at the scale and be sure. This point here, it looks like these are 3 each. 3, 6, 9, 12, 15, 18. Yes, so this is 3. 3 times that would be 9. 3, 6, 9. It would be right there, except it would be the other way. 3, 6, 9 down. It would be right there. Looks like that one's going to be the one, A. Okay, similar kind of problem here. We start with y equals g of x, and we my 2 and my 4 backwards. Let me just redo that one. Okay, so let's do this. Let's do it in stages here. Okay, negative 5, 0, negative 4, 2. Okay, so I'm going to write the points down. Okay, so let's start by writing the points down here. That's the original y equals g of x. Now the next stage to get x and y, I'm going to do, the first thing I'm going to do is get that minus. So I've got y minus y equals g of x, or y equals minus g of x. So notice I'm going to change the sign on y. So I'm going to leave the little x's alone and change the sign on y. So that's going to flip it over the axis. So it went up, boom, boom, something like that. Now it's going to be upside down from that. It's going to go down, boom, something like that, roughly. We could take our time and plot my points on the last one. Okay, next I'm going to think of doing the minus 2. So it's y equals g of x minus 2, which is saying y plus 2 equals, sorry, we got the minus here, minus g of x. So from here to here we replace y by y plus 2. So we really subtract 2 from the y's. So leave the x's alone and subtract 2 from the y's. So this is negative 2, negative 4, negative 4, 1, and negative 6. Okay, that looks good. So it just shifted it down. So whatever, it looks like this, but it's just shifted down too. And last stage, over here, the formula is y equals negative g of x plus 4 minus 2. So from here to here, look at it, we replace x by x plus 4. So you really subtract 4 from the x's. So we leave the y's alone. Subtract 4 from the x's makes this negative 9, negative 8, negative 6, negative 1, and 1. And so there's our graph. Now let's take a look at the graph. Negative 9, negative 2. This is the one they say is right, so let's check it out. Negative 9, negative 2. Negative 8, then it goes down to negative 4. Then negative 6 goes across to negative 4. Negative 1, 1, right there, so it goes back up. And 1, negative 6 down there. So it looks exactly like this one right here. Let's see if I can just go ahead and finish this thing out. 31. what's the right equation for this guy? Well, probably the easiest thing if you got a calculator is to just graph it. Well, you could graph each one and see which one works. Okay, so we could do it that way. Actually, I'm going to graph it just to check it in a little bit. In the meantime, let me go ahead and just think about it. It's like you start with y equals the square root of x, which is here. Okay, then it's been flipped upside down, so that's minus y equals the square root of x, or y equals minus square root of x. So that's here. It looks like we've been shifted to the right one and down 1, 2, 3, 4. Right one would be x minus 1. And down 4 would be y plus 4 here. So y equals negative square root of x minus 1 minus 4. So that should be the one, and that's the one they said here. But let's double check it by putting it in the calculator. Negative square root of x minus 1, close the square root, and then minus 4. And let's graph that, and hopefully that looks the same. And you could double check a few points. They've got a few identified for us there, so if we do trace and see what happens when you plug in 1, that gives us 1, negative 4. You can check that out. And if you trace it again for 2, for example, 2, negative 5, that seems to work there. And it looks like another one, good one to trace would be at 5, 5, negative 6. Okay, looks like we're in good shape there. Alright, here's another one where we want to just manipulate the graph that's there. It says which one is the y equals absolute value of f of x. So remember, y equals absolute value of f of x is this just the same as f of x if the f of x is positive or 0. So in other words, if the y is above the axis, it stays the same, the x-axis. But it's the opposite of that, f of x. In other words, flipped over the x-axis if the f of x is negative. So in other words, the part of the graph that's down here below will get flipped up. This part that's above will stay the same. So that's D. Okay. Find the variation constant in the equation of variation. Y varies, y equals k, directly as x, so that's times x. Or if they didn't even have to write the word directly, they could have just said y varies as x. And then they put an initial condition where y is 45 and x is 9. Divide both sides by 9, k is 5. So then the formula is y equals 5x. Very similar one here. Y varies, y equals k, inversely as x, so we're dividing by x. Y is 0.6 when x is 0.8. Multiply both sides by 0.6. 6 times 8 is 48, 2 decimal places, so it's 0.48 is k. And so then y equals 0.48 over x. This is what we have there. Remember to use your little symbol palette on the side to enter that stuff. The weight m of an object on the moon varies directly as its weight on Earth. M varies, m equals k, directly as the weight on Earth, which is E. So a person who weighs 164.41 pounds on Earth, that's E, times k equals 27.95 pounds here. These are both pounds, so the pounds cancel out. So k is 27.95 over 164.41. Alright, let's just get a number for that on a calculator, and I'm going to solve it, store it as k. So 27.95 divided by 169.41. 164.41. Okay. And I'm going to go ahead and just store that as k. Alpha k. So about 0.17. Okay. So that's our k value. And how much would a 208.24 pound person, that's on the Earth, how much would they weigh on the moon? So we're looking for m. So m is this k value that we just have times the 208.24. Well, I've got that. I didn't really have to store it as k. I've got it right there. And just say take that times the 208.24, and that gives us a 35.4 or something. Round off to 1/10, 35.4. Don't round off until the end, though. Okay, so just use all those digits it found for k, and then round off your final answer. Okay, we're almost to the end here. Maximum number of grams of fat that should be in a diet varies directly as a person's weight. Fat equals k times w, weight. Person weighing 96 pounds should have no more than 64 grams of fat. So k equals 64 over 96. Let me do that. 64 divided by 96. Store is k. 0.6 repeating. That's 2/3. So k is 2/3 or 0.6 repeating. So F equals 2/3 times W. And actually these have units. This is grams of fat per pound. So for every pound you should have for every 3 pounds you should get 2 grams of fat at most. So what's the maximum fat for fat intake for a person weighing 66 pounds? Okay, so you just put in 66 here, multiply by 2/3. I can do that without a calculator pretty easily. Let's see, that's 22 times 2 is 44. So 44 grams. Or just take k times 66. That's 44 grams, and so that's the maximum fat intake. Alright, Hooke's law. The distance d when a spring is attached to a hanging object varies directly as the weight of the object, so it's times w. If the distance is 65 centimeters, when the weight is 2, or really the mass, it's 2 kilograms, let's put 2, then k is 65 over 2, 32.5 is k. So the distance is 32.5 times w. Okay? Now, what is the distance when the weight is 7 kilograms? Okay, so you put 7 for the w. And it really should say mass, because kilograms is a mass measurement. Okay, 32.5 times 7. That's 227.5. Now they say put it in fraction form, so I can say math, change to fraction. That's 455 halves centimeters. Okay, next question. Are we done? No, one more. Last one. Stopping distance of a car after brakes applied varies directly as the square of the speed. So the distance equals, they call the speed R, the rate of speed, directly k times the speed squared, the rate of speed. So this value of k depends on various factors, the mass of the car, how kind of tires you have on it, and so forth. But once you've got all that fixed for a particular car, the k doesn't change. It's a constant. That's the way these variation problems work. The car is traveling at 80 miles per hour. That's here, 80. And then that is a distance of 400 feet. So k is 400 over 80 square. 80 square. Let's just go ahead and do that on the calculator. 400 divided by 80 square. 0.0625 is k. So the distance is 0.0625. I might want to store that as k, perhaps, but there it is. Okay. We might want k in a fraction form instead. We could do that. It was 1/16. So the distance is 1/16 r squared. So either way, it doesn't matter. Okay, and then if it's the same car, it's going to be the same k, the same formula. So this formula right here is going to apply, well, whichever version you want. And we want the same car. If we know the speed, we can find the distance. Or if we know the distance, how long it took it to stop, we can find the speed it was going. So if it's traveling 64 miles an hour here, this allows us to find the distance. So we take that number that we just had, the 1/16, times 64 squared, and that's 256. Distance is, the d is measured in feet, and the r is measured in miles per hour. They have to be consistent measurements from our original, and they are, so it's 256. And I believe that wraps us up for this practice test. You can use this to help you review and study for your exam. The actual exam will be very similar probably to this practice test, and remember, part A, you will not be allowed to use a calculator. Part B, you will be allowed to use a calculator, any one single calculator of your choice. And the difference is on the real exam, of course, it's worth more points, but it'll also be much shorter than this. Nowhere near the 38 questions, maybe half that or so, in that vicinity. Okay, good luck.